Okay, gang, here we go. Wave calculations. Let me choose my little pen dude right here. So, wave calculations, you should be familiar with a wave, how it works, and especially the three big things that you should know about. That guy there, this guy there, and this guy here. Right? So, pause real quick and ask yourself if you can remember what these three symbols mean. Alright, so this symbol here is wavelength. Yeah, and since it's a distance, we use meters to calculate it, or to keep track of it for its units. This here is our frequency. And we use hertz, or inverse seconds, Okay, and this is our energy. And I didn't give you a unit for this one yet, but just so you know, we are going to use the joule, capital J. Okay, so these are the units for frequency. This is the unit for energy. Alright, so here we go. Wavelength and frequency are related to each other using this formula here. Now, okay, so this little dash symbol is more like a bullet point. So it is c is the speed of light is equal to lambda times u. Okay, so it's equal to the wavelength times the frequency. The units for these, so remember wavelength is in meters and frequency is in inverse seconds. So when we multiply these together, you get meters per second, which is the unit we use for speed or velocity. Okay, c is a constant. It's defined as the speed of light, which we assume in these cases doesn't really change. It actually does change as you change mediums a little bit, but we're just going to assume that it changes such a small amount that it doesn't really matter. Okay, we're going to define it as 3 times 10 to the 8th. Okay, 3.0 times 10 to the 8th. Okay, so that's a defined number for you. So it will 3 times 10 to the 8th. Okay, so here we go. Calculate the wavelength of light emitted if the frequency of the light is 5.10 times 10 to the 14th hertz. Okay, so they give us hertz. You should know that this is the frequency. Okay, the first thing I do whenever I approach a problem like this, when I see the number and I look at the unit and I decide what that unit tells me. Well, I know that it's hertz, which belongs to frequency, so I'm going to define it as my new value. Okay, so we need to find wavelength. Alright, so we got to calculate the wavelength. I'll circle what I need to find. Alright, so I know the formula c is equal to lambda times nu. Okay, so when I need to solve for lambda, so in order to do that, I'm going to divide both sides by nu. Right, I'm going to divide by nu over here. My nu's cancel, so I get lambda is equal to c over nu. So now all I have to do is plug things in. Easy peasy. Lemon squeezy. So anyway, so speed of light, 3.0 times 10 to the 8th meters per second. And my new value, my frequency is 5.10 times 10 to the 14th hertz. Alright, which is inverse seconds, but doesn't really matter. Then I'm just going to plug these guys into my calculator. Remember, when you do this, use parentheses for the top and the bottom, the numerator and the denominator, just so it doesn't foul up your answers. Okay, so 3 times 10 to the 8th divided by 5 e to the 14th. And I got 6.0 times 10 to the minus 7th. Oh, you know what? I screwed up. Let me type it again. 3 times 10 to the 8th divided by 5.10 times 10 to the 14th. Here we go. This answer will be better. So you get 5.88 times 10 to the minus 7th. Alright. And the units for wavelength is meters. So there you go. Alright. So the wavelength of that frequency is 5.88 times 10 to the minus 7th. And then it asks us what type of light was emitted. Well, the only way to do that is by looking at an electromagnetic spectrum, unless you have the whole thing memorized, in which case you know more about it than I do. Okay, so I don't have it memorized. Alright, so here we go. So we had our thing that we were looking at was 5.88 times 10 to the minus 7th. Okay, so 10 to the minus 7th, this is the part we're going to focus on when we're looking at our electromagnetic spectrum. So we're going to find on our wavelength, remember this is our wavelength, we're going to find on our wavelength where 10 to the minus 7th happens. This is 10 to the third, negative 2, negative 5, we're getting closer, negative 6, negative 8, so therefore it has to fall in somewhere around here probably, right? Okay, so I would take, late visible or early ultraviolet light would be the answer. Because you really can't tell, based on this, because it's a logarithmic scale, you can't really tell where negative 7 is going to start. It might start in here somewhere, but it might also start, in the ultraviolet area. So anyway, so anywhere kind of in there would be an acceptable answer. Alright, the other formula we need to know is energy and how it relates to frequency. So the energy of light and frequency, what? Alright, forget. There you go, ignore that. Alright, the energy of light and frequency. So E energy is equal to h times nu. Now h is defined as Planck's constant, okay? So it's always going to be this number here. Super handy. This guy named Planck, or Planck, was a really important guy that helped us discover a lot of things about light, especially in electrons. So anyway, so he has his own constant. It's 6.626 times 10 to the minus 34th. And the units are dual units, joules times seconds. Okay? So, and then the nu, remember, is still frequency. So we have Planck's constant times our frequency. Okay, so it's always going to be 6.626 times 10 to the minus 34th. So it says, what is the energy of radiation with a frequency of 3.20 times 10 to the 11th hertz? So what is this value here? How do we know? Well, this says it's hertz, so that means it must be our frequency. Okay, so energy is equal to h times nu. So it says what is the energy, right? That's what we're trying to find, so we don't even have to rearrange our equation. We're just going to plug things in. So h is Planck's constant up here, so we're going to take 6.626 times 10 to the minus 34th joules times seconds, and then we're going to multiply that sucker by our frequency, 3.20 times 10 to the 11th hertz, or inverse seconds. Now if you look, that means this unit here, that s is on top here, it's on bottom here, so therefore those s's cancel and we're just left with joules, which is good because that's what we want, because we're looking for energy. So I'll plug this guy in, 6.626 times 10 to the 34th, minus 34th, times 3.2 times 10 to the 11th. We get 2.12 times 10 to the minus 22nd. What did I say? 2.12. Oh no. Oh no, my calculator. Times 10 to the minus 22nd. Joules. And there you have it. On the practice sheet, there's a couple of problems where you have to use this formula here to find the frequency, and then use the other formula from the previous slide to find the frequency, or the wavelength. So you might have to take both equations, both E equals h nu and C equals lambda nu, to solve for the wavelength. See if you can't give those a shot and figure those out. Let me know if you have any questions. Good luck.